Shalom Aleichem, Assalamu Alaikum, teman-teman, guys. And today we are going to study the Incubator grid investigation. And then today we are going starting from the course. It's the adaptive sizing method for the meshing purpose. Okay, as we can see, we actually don't need to set the parameter set because there is no parameter tick checkbox for the medium, coarse, and fine adaptive sizing. So as we can see here, we can at the first time we need to generate the mesh first, and then after we put this one, and then we can go to the mesh, and then we can set the sizing. So there is display, defaults, and this is sizing, and then there is coarse. There are three actually: coarse, medium, and fine. For the grid investigation, it would be better if we use this. But if you wanna do this one parameters, you need to check this box and then need to resize this one, so you can calculate. You can put a variative number on it, but we are not doing this at this moment, so we don't do that today. We'll just do it manually for the grid independence test for this incubator. As you can see, it's already coarse, and then you need to generate mesh again, and then solve mesh, and then go to the mesh, and then adaptive sizing, coarse, and then generate mesh again. And then after it's done, you can close this part, and then you can go to the setup, double left click, and it's okay, double parallel at that box. Okay, as we can see here, wait, we're going to use time steady because it's a big one, and then it's not going to be transient because it would be a long of time needed to proceed the simulation. Wait. Oh my god. What's wrong? Because there is something wrong, I think we can go. I've exported the mesh before, so the way to export it is like this. I have exported the coarse mesh only to the coarse.msh like this, from that design into the msh folder, so it can be inputted into the another workbench if there is mistakes. So I will show you how to export it. Export the mesh into the .msh, so you can go to the workbench and get the the better condition for simulation. Okay, as we can see here, because at the time setup is not working really well, so I do the mesh export and then I import again. I don't know why it is an error like that in my computer. Okay, as you can see here, the mesh, this is the meshing side, and then we can go to the file and then export. It's in here, not meshing database, not geometry, it's a mesh. And then the mesh, we are going to Fluent input side, and then it's going to be .msh, and then we are going to say it export and then go to the course or what it is, or 2 for example, and then you need to go to the save like this for example, and then the mesh translation to Fluent was successful, and then we can close this one. And then we are also able to close this one if it's not opening. No, this one, it's double precision. Then I hope it's working in here. Okay guys, as we can see here, it's failing again, and then there is nothing here. Then we can close it. If it's getting worse, you can reinstall it. Okay, and then we are going to type the workbench again. Okay, we can see here, and we can right click here, import mesh, and then browse. We have input the second mesh, and then we can use second mesh or coarse mesh. It's all the same. Okay, as we can see here, it's already green. If it's not green, you can right click like this and then update. Okay, as we can see, there is double precision. Okay, it sounds like it's normal. I hope that it's going to open the mesh pretty well. Okay, there's no problem here. And then as we can see here, we are going to set it at steady rather than transient, because steady takes better time efficiency. And then we are going to the viscose. Actually, you can go to the K epsilon for the standard or RNG, or K omega for the SST. I'm using K omega, but it would be right if you are using K epsilon and RNG. It doesn't affect a lot in the simulation. This is SST K omega. And then we are not going to change the fluid and solid. If you are going to change, you can do that. You are able to do that. And then cell zone condition, it's already right, fluid and solid. And then the boundary condition, we are going to change this one with the 0.45 meter per second. Okay, this is already right. And then the outlet boundary that requires the backflow reference frame, gauge pressure, We don't need to set it up to the another parameter. And then about the walls, we just need to set it up as a non-slip assumption, as this one. So actually there is no specific change. And then it's really important to change in the solution in monitors. This is very important to set it up to 1a-6 as the absolute criteria. This one. And then this is the convergence criteria. It's very important. The convergence criteria. Okay, it's okay. And then the methods and controls need, there is no need to get changed. And then we are going to use the standard initialization with ozone. Ozone's gauge pressure 0, it's okay, initialize. This is gauge pressure 0 atm because if it's the absolute pressure, I think it's absolute, I think it's 1 atm. Okay, it's already get initialized so that we can already run the calculation after it. We can check it up with the contours first with the pressure. Static pressure but total pressure in the interior incubator. As you can see here, total pressure all is 0. It's already filled actually with this one. This is gauge pressure, total pressure in gauge. And then we are going, so it's 1 atm inside it. And then we are going to run the calculation easily by 1000 iteration. Then you guys need to calculate. Okay, we just need to wait for it. For the 950 iteration remaining. Okay guys, after that you can click OK in the tick box. In the box, I actually already check it. I mean click it at the complete and done. It's already done, and then we can go to the contour. For the contour, we can check the pressure, and this is total pressure. And then we can display the interior incubator. It feels like this. I think it's still, oh my god. Oh my god, it's okay. It feels like this, but actually we have to make the surface for the inlet because it's only at the outside. We need to make a new surface, and then it's a plane. Okay, at the first time we need to make the XY plane. XY plane is okay. We are going to make the XY plane plus first. Create. Oh, we can actually name it SXY XY plane, create, and then the next one is 0.74 25. Zero 0.4. Then this is set explain. Create, and then this is YZ plan. Okay, we have create everything here: XY, YZ, and Z and ZX. Then from here we can see the, oh, sorry, we need to uncheck this, then check this, and then this one. And then go to this one. Okay, we got this color. It's around here. I don't know why it's getting like this. I don't know, but its color is this, so it's true. And then the next one is this. I don't know where is it at. Oh, here we go. And then okay, it's like this. So you can snip this all, and then the ZX, it's like this. Where is it at? Oh, it's at this. So it would be looks like this. Okay, I think it's already done. Then after that, you can check the vectors of it. It would be looks like a velocity vector. Surface should be like that. This one, XY plane. Okay, as we can see, it feels like this. It looks like this. It's pretty a lot, but you can change the scale from 1 to 0.5, and then save or display, or maybe a little bit lower, 0.1. Okay, it would be better. It looks better, I think. And you can zoom it, so we can see it like this. Okay, it would be the same for the YZ plan too, like this. This is the YZ plan, looks like this. And then the ZX plan also. Okay, the next one is the path lines. Path lines is look like it's released from surface inlet boundary, then save and display. So it feels like this. Okay guys, thank you for watching, but actually you guys need to do it with the fine mesh, adaptive mesh sizing, because this is the coarse. Coarse is not the, I think it's the worst one for the simulation. This is the coarse, not the fine or even medium. So this is the worst one. So this is only an example. So you guys can do that with the fine meshing additive method. So you can use this one to set the path lines, vectors, and then the contours. Okay guys, thank you for watching. See you in the next video. Shalom Aleichem. Assalamu Alaikum Warahmatullahi Wabarakatuh. Bye-bye.